Okay, continuing on with part C of example 1, we have our equation, but the big question is, when will the number of bacteria be 50,000? Now again, that equation that we're looking at is y equals 5,000 times 3 to the t over 10. Now again, it can be very, very tempting to think that this problem can only be done with a calculator, but I do want to point out that you could still solve and get an answer without using technology. Look, when they're saying, when does your population hit 50,000, you're really saying, when does y equal 50,000? And then ultimately, we're solving for t. Now, as we look here, you can pretty much see quickly that we can divide both sides by 5,000. You can see our zeros cancel out. 50 divided by 5 is simply a 10. And then we've got 3 to the t all over 10. And the big question is, how do we get t down? Well, how did we do that the other week? We took a log on both sides. Now, by the way, you could take a log base 3, you could take a log base 10. What you see most frequently, though, is just a natural log. By the way, those other answers are good, too. Look, I'm going to bring down the t over 10 here. And then just realizing, hey, I'm trying to get t alone. I'm trying to get t all by itself. It's just a little bit of algebra right now. For you to see that getting t all by itself, I'd multiply both sides by 10 and simultaneously divide by the ln of 3. Please understand, this answer right here is a valid solution. Now, without a calculator, you might get a little bit upset saying, well, wait, I don't have the exact decimal that I'm looking for. Make no mistake about it, you could, no doubt, do that real fast. You could, take your calculator out and just do an alpha y equals. I think it's helpful to be able to see that. But please do understand that if someone just asked you to get an answer, what I just circled over there is valid. 20.959 hours. 20.959 hours. The other answer that I circled, however, is good. Okay, we doing okay? All right, let's go to number 2 and half-life. Wow, you're going to see half-life in these problems. No doubt about it, one of the most famous applications. Radium decays exponentially. It has a half-life of 1,600 years. Wow. Find a formula for the amount Y remaining from 50 milligrams of pure radium after T years. And no doubt about it, we're still going to use this very basic formula. If you have a half-life problem, that's what you're working with. And here's where kids can get a little upset, though. They might say, okay, I'm reading from the context of the problem, Mr. Dobner. I know you're beginning with 50 milligrams, but I'm looking back at the other problem, and I certainly didn't get all the information like we did in example 1. In example 1, they give you quite a bit, and here it's maybe not quite as much. Well, they did give it to us. They left off a little something. They're saying, look, your half-life is 1,600 years. So yes, you're going to start with 50 milligrams of radium. And you could say, well, in 1,600 years, what would the mass be of your radium? 25. It would be half of that, wouldn't it? So that's that little extra step that you just have to use some common sense on. And say, well, I have to take half that mass. Now, of course, I'm going to divide both sides by 50 and, very quickly see that I arrive at 1/2. And here we go again. I'm ultimately not solving for C. You could do that. But in calculus, generally, we solve for e to the c. It's actually easier. It really is. So, you look right here and you can think, wow, we're so close to getting e to the c all alone. Unfortunately, I've got that 1600 multiplied to that c up high in the exponent, and I want to get rid of that 1600. How might we do that? Yeah, raise both sides to the reciprocal 1 over 1600, and that can look very unsightly, of course. You look at that, you think, oh my gosh. Well, powers to powers get multiplied together. Wow, I'm left just with e to the c, and then we've got this 1/2 all up to the 1 over 1600. And of course, like I was writing earlier, what you could think about is this equation, guys, is really like y equals y naught e to the c raised up to the t power, if you'd like. You could definitely think of it that way. The reason why you might want to think of it that way is because then you could say, well, my y naught is 50. Then I've got 1/2 to the 1 over 1600. That's my e to the c. And then I'm going to raise that up to the t power. Well, I hope it's not too much of a stretch for you to see that your final form for an answer is 50 times 1/2, raise it up to the t over 1600 power. And that, guys, will be your formula. The benefit now is you can plug in any time that you'd like. And, however many years after where you're beginning, you can find your mass that you're really looking for. Well, let's keep going with part B. They're saying, when will the amount remaining be 20 milligrams? So they're saying, when is y going to equal 20? So we're trying to find the time ultimately. Well, go back to your wonderful equation that you've got right here. And we're going to say, let's let y equal 20. And wow, all we have to do is solve for t. Notice the irony here. We're in a calculus class. For this problem, we haven't taken a derivative. We haven't taken an integral. Nothing like that. Okay, we just need to go back and do some algebra. Solve for t. How do I do that? What should we do to both sides? Divide by 50. And when you divide by 50, guys, you'll wind up with 2/5. And here you've got 2/5 is equal to, here's your 1/2 t all over 1600. And wow, I really would like that t to come down. What should I do to both sides? ln, natural log. And wow, you guys get the idea. So very often it's the same basic premise. You can now bring that exponent down. Tell you what, simultaneously on the left, I'm going to remind you of that subtraction property. Wow, look at that. So things are working out, just fine. Tell you what, let me slide this over just a little bit and we can continue up here. And how about I multiply both sides by 1600, just to get us started a little bit here on the left. And on the right side, well, I could do the same thing that I did with that fraction. I could change that into the natural log of 1 minus the natural log of 2. And we're so close to just finding t all by itself. But my goodness, as we're trying to get that t alone, first realize, hey, what's that natural log of 1? 0. You guys remember that? Natural log of 1 is just a 0. And real quickly, kids will say, well, now I get it. Divide by negative natural log of 2. You could do that. And your t, if you want to bring that negative up on top, you're going to have a nice, simple answer that looks like this. even without a calculator, guys, you have found an answer. You found a solution. Now, of course, it's not too satisfying to say, aha, it's this many years that you're going to arrive at 20 milligrams. That's where, it sure is nice if you do have a calculator and you can get this thing typed out. But please hear this loud and clear. You don't have to, know that. You could just say, hey, whatever this answer is, that's how many years it will take to arrive at our designated 20 milligrams. But just typing this thing out, bring down here, you get a natural log of 2. I would expect this to be pretty big. It took 1,600 to just cut your mass in half. Look at this, 2,115.085. 2,115.085 years it's going to take to arrive at 20 milligrams. Your half-life is pretty big. We doing okay? All right, one more problem. Let's take a look at Newton's law of cooling. And tell you what, maybe we should have a separate video for that one.